Until now, we've been talking about forces, and we mostly talked about the weight, any driving force of an object. We talked about the normal contact force between two surfaces. We talked about tensions, and that was mostly it. But we are forgetting a very important force that happens every time you have two objects in contact, but that are trying to move one against the other or actually moving. The normal contact force does not depend on this, but this force only happens if you have one object trying to move against another one or actually moving. We are talking about friction, okay? And what is the main characteristic of friction? The main characteristic of friction is that it always opposes the motion or opposes the attempt of one thing to start moving against another one. And it only happens, obviously, if you have two objects in contact. It's a contact force, not a normal contact force, but actually a tangential contact force, okay? If I have my hands over here, a normal contact force would be like this. A tangential would be like this, perpendicular to the normal, all right? So, what does it depend on? It depends actually on the contact force between the two surfaces of the two objects. The higher the contact force, the higher the friction. The lower the contact force, the lower the friction. Makes sense, right? So it will depend on the value of n, the normal contact force. But it will also depend on the nature of the things that are in contact with each other. And this depends on what? Depends on the materials of the surfaces in contact. For example, if you have rubber and velvet against a wooden floor, the rubber has a much higher friction than the velvet, right? So it depends on the materials. It depends on the roughness of the surfaces. If you have granite and marble, two different types of stones, the granite is much more rough, or can be much more rough than the marble. The marble would have a much lower friction, even if everything else was the same, all things being equal. And obviously the area of contact between the surfaces. The wider the area, the bigger the friction, okay? You don't need to worry about the specificities of each one, because all of these, they are boiled down into one parameter, which is called the coefficient of friction, represented by this Greek letter, which is a mu, which by the way has no units, okay? So these are the two parameters that are going to define the intensity of the friction. The direction you already know is opposite to the motion or opposite to the direction where the object is trying to move, all right? And the maximum value of the friction between two objects is given by the product of these two, the coefficient of friction and the normal contact force. This is the maximum friction between two surfaces, but is not always the actual value of the friction. It will depend on the circumstances. Let's see. Let's say that you have a 5 kilogram object on top of a horizontal surface, and the coefficient of friction between the box and the surface is 0.5, all right? This maximum friction, which is, by the way, called the limiting friction, is going to be the product of the coefficient of friction by the normal contact force. How big is the normal contact force? Well, the box is not going anywhere in the y-axis, so you know that the normal contact force equals the weight in terms of magnitude. So if the mass is 5 kilograms, the weight is 15 newtons, sorry. So the normal contact force is also going to be 50 newtons, right? I hope that by now this is trivial for you. So the limiting friction, the maximum friction that can occur between the box and the surface, is 0.5 times 50, which is 25 Newton. This is the maximum value. But let's say that right now you have the box on top of a surface, is not moving, and you apply here a 10 Newton force, that way, to the right, okay? Is the box going to move? The answer is no. Why? Because opposite to this attempt of making the box move, you will have a friction force that needs to be just as big as this force. It's not going to be 25 newtons. Why? Because if this was 25 suddenly, it would be weird, right? You would try to pull the box that way, but instead, because of friction, it would actually go the opposite way. It doesn't make sense, right? So this value over here is the maximum value that the friction can have. Right now, it only needs 10 newtons to make the box not move. So how would you translate this into maths? Xy on X, you have the force equals the friction, but here the friction is just the 10 newtons. You don't apply that. This is just for reference for you to know what is the maximum value of the friction. In the y-axis, the normal contact force equals 50 newtons. Let's now put 25 newtons, okay? So right now, you have a 25 newton force that way. What is the maximum force, friction force that it can be? It's 25 newtons. So is the box moving? No. It's on the verge of moving, but it's not moving yet. So the representation of the forces is still the same, the difference being that the friction is now 25 newtons. What if you apply a force that is bigger than 25 newtons? Let's say 40 newtons. I'm not sure what this line is. I need to just take it out later. In this case, now you have a force that way that is bigger than the maximum friction on the opposite way. So now you will have an acceleration that way. In the y-axis, you have the same circumstances, but on the x-axis, you have the force minus the friction equals the mass of the box times the acceleration. So what is the force? It's 40. What is the friction? Now it's 25. The maximum can be, all right? Equals the mass of the box, which is 5, times the acceleration. Just do the math, and the acceleration is 3 meters per second squared. See? The maximum friction that can occur between two objects, which is again called the limiting friction, is the value that you are going to plug in if objects are indeed moving. Everything else that you need to know is just to use these concepts in different situations, then combine with everything that you've learned in this chapter, and just treat friction as another force. The only thing is that in order for you to calculate, you will need the value of n. So you will need to decompose things in the x-axis and the y-axis and use the information on the y-axis, namely the value of n, to plug in on what's happening on the x-axis, because friction equals the coefficient of friction times n. So you need this in order to solve things regarding to that. So you'll need to decompose in y to extract information that you are going to use on the forces represented in x.